We're going to start in on graphing quadratics in this video. Quadratics, you might remember from before, are anything that has an x squared term as the highest degree. So y equals x squared is our most basic quadratic. We're also going to be graphing y equals 1/2 x squared. So there's this little tweak that it's multiplied by 1/2. Spoiler alert, when we graph a quadratic, we get a parabola. It could be a wide, slow-growing parabola. It could be a narrow, fast-growing parabola. It could be a parabola that's opening downwards or to the side, though we aren't going to do that in this class. But let's talk about how to graph these. So I took the liberty of already filling out the table for y equals x squared. So when x is -3, -3 squared is 9, and so on. I also looked at the rate of change here. So the difference between 9 and 4 is -5, 4 and 1 is -3, and so on. Notice the pattern of this 1, 3, 5. We also know what the next number in this sequence would be. It would be an increase of 7 because we're just going up by odd numbers, and we know from before that for quadratics, the change of the change is constant. So all of these differences should be a difference of 2. Okay, so if this is an increase of 7, 9 plus 7 is 16. And sure enough, for the corresponding x value, that would be a 4. 4 squared is 16. Let's see what happens when we multiply it by this 1/2. So when x is -3, -3 squared is 9. 9 times 1/2 is 9/2. You may notice a shortcut here. Let's do another. -2 squared is +4. 4 times 1/2 is 2, or what was originally 4/2. -1 squared is +1. 1 times 1/2 is 1/2. 0 squared is 0 times 1/2 is 0. And looking at these numbers, what we have is we have 9, 4, 1, all multiplied by 1/2. 9, 4, 1. So it's essentially like we're taking our original input and just multiplying it by 1/2, which is exactly what that equation is telling us. So that means what goes right here will be, that's not a 0, that's just a circle. What goes right here will be 1 times 1/2. 1/2, 4/2, also known as 2, and 9/2. Looking at the pattern there, that's a decrease of 5/2, a decrease of 3/2, a decrease of 1/2, an increase of 1/2, an increase of 3/2, and an increase of 5/2. So we still have that 1, 3, 5 pattern. It's just scaled by a factor of 1/2. Now let's graph this. One of the most important parts of graphing a parabola is realizing where the vertex is. So on y equals x squared, this is where the numbers on our table, they were going down and then they started going up. That bounce point is the vertex. So the vertex is at 0, 0. And the y values form a mirror image on either side of the vertex. So in this graph of y equals 1/2 x squared, we start at the vertex, and then the numbers form a mirror image going up and going down from there. So we could plot the points, but Desmos does a better job of graphing than I do, so that's what the curve looks like. Notice it is wider looking. This means that the growth is slower than this one of y equals x squared. I'm going to call this one of x squared the parent function. All right, make a table for y equals x squared. Make a table for y equals 2 times x squared. So we already know the rough pattern that this is going to follow. The first problem we multiplied by 1/2. In this problem we're multiplying by 2. So I'm going to just grab my inputs and just multiply each one of them by 2. 18, 8, 2, 0, 2, 8, 18. And once again, where I'm getting those numbers is I'm taking 9 and multiplying it by 2 to get 18, 4, multiplying it by 2 to get 8, and so on. Again, notice the pattern here. So the rate of change, this is a decrease of 10, of 6, of 2, increase of 2, of 6, of 10. And so another way to look at this or think about this is 2 times -5, 2 times -3, 2 times -1. So there's our lovely friends, the 1, 3, 5 pattern. There's the 1, 3, 5 pattern again. 2 times 1, 2 times 3, 2 times 5. So what you should start to think about is if we can start at the vertex, if we can figure out where that vertex is, we should be able to follow a pattern. If this pattern thing just doesn't make any sense to you, that's okay, because still need to start at the vertex, but then you can just build a table and graph from there. So let's go ahead and graph this. And again, what we want to do is we want to identify what the vertex is. So I see that my numbers are going down until this point right here at 0, 0, and then they start increasing again. That means that 0, 0 is our bounce. That's our input. And I notice that these numbers are changing faster than over in the parent function. And so what that means is that our parabola is going to be narrower. It's going to grow faster. Putting some of these ideas together, this is multiple graphs right here. So we had f of x equals x squared. So that was our center blue line. So that was what I called our parent function. Then when we multiplied it by 1/2, what happened is the growth was slower. It didn't change as quickly. When, for this kind of yellowish golden, when we multiplied it by 2, the growth was faster. It turned into a narrower parabola. What do you think would happen if we had y equals -x squared? What would happen is that parabola would open downwards. So some takeaways. The graph of a quadratic function is a parabola. Parabolas are symmetric about the vertex. If you can find the vertex, you can graph the parabola. If you can't find the vertex, this is going to be a rough section. If f of x equals ax squared, the growth is 1 times a, 3 times a, 5 times a, and so on, per change in x values. If a is a big number, which means anything over than 1, the parabola grows faster. It appears to be narrower. So what would make this true? This is an absolute value of a is greater than 1. So that means if a is 2 or 3 or even like 1.5 or 10, the parabola is growing faster. What these absolute value signs mean is that we could also plug in negative numbers for there. So if a was a -3, the absolute value of -3 is +3. That still is greater than 1. So again, that means the parabola is growing narrower. It just, the thing is, if a is negative, the parabola is opening downwards. So if you have something like y equals -3x squared, the parabola is opening downwards, and it's opening downwards pretty quickly, faster than the parent function would open. If the absolute value of a is less than 1, so in this case that would be y equals 0.4 x squared, or y equals -0.1 x squared, or y equals 4/5 x squared. All of these parabolas are going to be wider than the parent function, or going to appear wider than the parent function. I have to be careful here because all of this is about the growth. It looks wider because it's growing slower. And that is everything. Thank you.